That work for you guys?
Yeah.
All right.
Well, my name's Mike Howard. I'm Whiskey Alpha Zero, Sierra Papa Golf, and I reside in Elkhorn, Iowa. And we have a corporation called Liberty Labs Incorporated. We calibrate antennas from 5 hertz to 70 gigahertz. I'm going to give you a little background on our site. We have the world's largest antenna range. We calibrate roughly 16,000 antennas a year on our site. We calibrate antennas for every corporation in the US, Canada, South America, Japan, Southeast Asia. We do work for all the automotive companies, Army, Air Force, Navy, Israeli Defense Forces, Australia, New Zealand. These antennas are used to ensure product compliance with federal communication requirements. So if you ever look in the back of your computers and you see CE mark, compliance for Europe, UL, TUV, any type of electronic device has to be qualified for regulatory requirements within the United States or internationally. So we see these antennas, they come back on a yearly basis. I turned my hobby into a business. I started when I was 10 years old when I became a novice operator in southwest Iowa. And so I worked for various companies in testing of electromagnetic compatibility. And I finally got to the point, well, I'd like to do it for myself, so I decided to calibrate antennas. And so in 1992, I set up an antenna range in my backyard. My first building was my Boy Scout tent. I would lay on my stomach, and I had a spectrum analyzer with a space heater. I'd run outside the tent. I had a ground plane in my backyard. I had a rope pulley system to raise the antenna up and down the tower, run back into the tent, take the readings by hand. End of the day, I take all that handwritten data and put it into an Excel spreadsheet. And this grew into the world's largest antenna range. We have a site that's larger and more accurate than what the United States government has at the National Institute of Standards and Technology in Boulder, Colorado. They've actually come to our site. I have, there's 3 competitors in this arena, and my competitors come to me to use our site because of the accuracy of it. So I'm going to give you 3 presentations tonight. First one is a little background of the antenna calibrations and some of our sister companies, WorldCal. We calibrate network analyzers, spectrum analyzers, signal generators, voltmeters, power sensors. We do work for NASA in a little town of 650 people. NASA sends their equipment to Iowa to be calibrated. So I'll give you a background of our companies. Then I'm going to give you a background into a very special calibration. One of the antennas we calibrated is now circling the planet Mars. We did work with the European Space Agency and the University of Iowa. It's a 6 megahertz dipole that's on the Mars Express that was used for ground penetrating radar to detect water. The antenna worked great on our site, it worked great on the satellite, and they were able to detect water with this. We're also working with the university on another satellite program called Europa. They're going to fly another satellite, this time with about a 3 megahertz dipole, to detect water on one of the moons of Jupiter. So it's a moon called Europa. And then finally, I'm going to give you a short presentation. Last year, in May, I did my first de-expedition to the Dry Tortugas on Fort Jefferson. That's about 70 miles from Key West. And learned a lot from that. I'm hoping to do more de-expeditions. So I'm going to go through and give you some background. This is our test site. This is a 50 by 80 meter ground plane. We have it, so basically a reflective ground plane. We typically have a transmit antenna and then a receive tower. This is made with 260 tons of steel. There's 2 miles of linear welding in this. That whole metal deck is floating on 847 cement posts. On those posts we have 3,200 volts of vertical adjustment. So as the ground changes or shifts, we can actually level this ground plane to within plus or minus 4 millimeters. So we're out in the middle of the field, we're down in a valley. Your cell phones don't work very well. We have an underground site where the equipment is placed underneath. We do calibrations at 3 meter distance, 10 meters, out to 30 meters. And I'm going to be showing you some more of the antennas that we utilize. So this is on a 40-acre farm, and this was built in 1998. We started calibrating antennas in my backyard in 1992. 1998, we secured a loan for $500,000 to build that site. Today, it'd be about $2.5 million with prices for the construction materials. And it has worked out quite well for us. This is one of our other sites. This is kind of our all-weather site. The ground plane is made of galvanized wire mesh with a 1/4-inch spacing. This is an insulated dome. This is a type of dome they use up in Alaska. So we calibrate the antennas. We can go up to 10 meters in distance for these antennas. It's not as accurate as the other site. So we have two levels of services that we offer our customers. One is standard calibration, and the other is the high precision calibration. Okay, just another view. We've got lights. We can work at night. So, and then we have underground access. We have heliax cables running out to the antennas. And we have to lay those down at night. I have deer that try to come and walk on the ground plane. They get their antlers cut in our guy wire, so we lay them down. Plus, it's really funny, when the geese are starting to come back, they think it's water. So all of a sudden they're getting close, and they got to really start flapping hard to get off because they realize it's not water. So we get some funny things there happen. Okay, this is a close-up of the situation. What we're doing is we're measuring the insertion loss from the transmit antenna to the receive antenna. What we're doing for our customers, we're telling them really two things. What is the correction factor? So if they're receiving a signal, what is the actual field strength? And so we tell what the correction factor of the antenna. Now we also tell the customer the reverse. What is the gain of the antenna? These are bilog antennas. These go from 30 megahertz to 6 gigahertz. And so companies like Ford Motor Company will use this antenna to measure emissions or radiated emissions coming from the vehicle or from another source. What we do is we use what's called a 3-antenna method. This antenna has a direct signal that comes into this. There's also a ground bounce that comes up. What we do is we raise this antenna from a 1 to 4 meter height. And what we're looking for is when the two signals are in phase, where we get maximum. So we put a spectrum analyzer or a network analyzer, we put it in a max hold situation, and then we determine where the maximum signal. The beauty of our site is we can, when we calculate these, my theory, by mathematics, the measurements are almost dead on with theoretical mathematics. That's how accurate this site is. We also use very special cables. You see the coax here has a lot of ferrite beads, and they're about every 6 inches. We do that to prevent the cable shield from becoming a radiator. We also bring the cable back out at least a couple meters back, so that when we go vertical position, that this doesn't act as a reflector. So this is all computer controlled. We do different transmit heights. We do maybe a 1 meter, 1.5, 2 meters. Sometimes we go up to 4 meters. We'll do a near free space calibration where we'll go up very high with the antennas to get that type of measurement. Okay, this is just another view down the valley. And again, this is a 3 meter distance between. We calibrate year round. My guys, we've gone out to 20 below. We put on our coveralls and we calibrate. And we have 7 snow blowers that we use to clear that site of snow. And here you can see a little bit more of a close-up of the ferrite beads on this cable. And you can kind of see, this does look like water, doesn't it? You know, the ground plane. To paint that was a $30,000 cost to paint that with a special epoxy for it. The steel plating that's used in here is a special steel. It's called Core 10. It has copper and nickel mixed with the steel. So the underneath side, Core 10, once it starts rusting, it will stop. And so it will not continue to rust. So it's a special type of metal plating that we invested in. It's called Core 10 that has copper and nickel mixed in with it. This is a different type of antenna. This is a biconical. And it's more like a folded dipole. This was developed by the military back in the late 1940s. Another term is a bullwinkle antenna. It looks like the antlers of Bullwinkle the moose. This typically goes from 20 megahertz to 200 megahertz. Some go up to as high as 300 megahertz. They're either a 2-to-1 or 4-to-1 type balun, or a 50 ohm or a 200 ohm input impedance for these. Again, thousands of these we calibrate throughout the year. And my guys, they'll do maybe 20, they can do maybe 20 to 25 of these in a day. And that's a variety of different conditions, 3 meters, 10 meters, horizontal, vertical, different transmit heights. So there he's getting adjusted on the tower. Now you can see the two arrangements. This is basically here about a 2-meter transmit height, and this antenna will be going from 1 to 4 meters. These are log periodic antennas. While I'm trying to show you some of the more common types of antennas, we get a variety of antennas. And we even had a very interesting project years ago. We even calibrated a woman's brassiere with the underwire. We had the FDA came to us, and we were concerned about coupling of RF for breast cancer. So we actually raised and lowered so that was very unique.
Wow.
These are log periodic antennas. These typically go from 200 megahertz up to 1,000, possibly 2,000 megahertz. So, and again, you can kind of see the close-up of the ferrite beads on there. This just shows the bicon antenna up at the higher height. This is on the transmit antenna. This is just a close-up of the antennas. On this metal plate, we go out 10 meters with wire mesh that slopes down in. So we had concerns about the transition of a perfect conducting metal plane. So we continued out with wire mesh and then serrated so that if we have any ground currents flowing in that metal plate, there's a smooth transition from the metal decking to earth. And we have very moist conditions, so we don't have any problems of the earth getting too dry, and that's worked well. We've used special types of time gating on our network analyzers to look at multipaths as far as reflections. And you can see the trees are back here, and it's less than a tenth. We have accuracies of about 0.2 of a dB, worst case on this site. And we can consistently repeat that from year to year. There's just a close-up of the log periodic that we have on the antenna there. Again, we fabricated our own towers. These are basically a plastic, I forget what the material is. And we also characterize the issue of any concerns of interaction of this material with the antennas. Oops. I want to go back. This one, these are dipoles. These are calculable dipoles. We actually characterize this by the full S parameters of that antenna. So the dipole is always our most accurate antenna. That's always we reference everything back to. So when we calibrate a customer's antenna, it's related back to a dipole. These are made in England, and these are $35,000 for those dipole antennas. And but they're calculable. We can accurately measure the S parameters and determine the characteristics of this. The elements are precision cut for each frequency, so like at 30 megahertz, 35, 40, 45. Very time consuming. It can take us up to 6 hours, sometimes 8 hours to do a full calibration with these dipole antennas. We also do some very unique things. This is a strip line. We basically feed in, this is a input here, standard coax, transitions up. It's terminated at 377 ohms, which is free space impedance. So what we do is we create an electric field and magnetic field. Maybe a little hard to see, but this is a rod antenna. This rod antenna is an active rod. It goes from 10 kilohertz to 30 megahertz. So what we're doing is we're generating field strengths here at these lower frequencies. For me to set up a 10 kilohertz long wire antenna, that gets to be pretty cumbersome, long wavelength. We also will test a loop antennas in here, so we can get very high field strengths, and by knowing the net power flowing in here, we also measure the complex impedance. So I know what the impedance is at this point, and then putting that in my equation, I can calculate what the field strength is at that point. So this is a rod antenna with a 377 ohm. We'll do this out in the open site. We also have this indoors as well now. Now you can see here a loop antenna. By the way, we're really getting into frequencies below 30 megahertz. There's probably a lot of concern to ham operators. I'm working with the Federal Communications Commission and the Department of Food and Drug Administration right now. Wireless power transfer. You will in the future walk into a room. There will be antennas mounted in these walls. Your cell phone will be charged as you walk around. That's being done at around 7 megahertz. There are also 50 kilowatt systems that are designing to charge electric vehicles. So there's a lot of safety concerns. If your cat or your kid gets underneath the car with 50 kilowatts of power, that's an issue. But that's being pushed aggressively. Japan, Australia, China. Right now, wireless power transfer is in full swing for small devices and for large devices such as electric cars. So we're doing a lot of work with loop antennas in the below 30 megahertz region. I have a loop antenna that's 4 meters in diameter. I don't have a picture of it, I'm sorry. And so the magnetic fields basically circle this top plate. And so we have the circular effect. Take the old left-hand rule with the magnetic fields that circulate around that plate. So then we can accurately calibrate loops of various sizes. And we have some loops up to 4 meters in diameter that we're dealing with. Okay, I'm going to move to WorldCal. When we started Liberty Labs, our customer said, we do such a good job, how about the equipment that's connected? So we have another company, it's part of the overall Liberty calibration team. WorldCal calibrates everything again from 5 hertz up to 70 gigahertz. This is where NASA sends their equipment to be calibrated in the little town of Elkhorn, Iowa. You don't have to go to California to have high tech. You can do it in small rural communities throughout the United States. You do not have to be in large metropolitan areas to have high tech. You can do it in little tiny towns like Elkhorn, Iowa. So this is some of the equipment. We do a lot of microwave, RF, power sensors, voltmeters. We do surge, burst, flicker, harmonics, just a variety. And again, we have in the thousands of items that come through to be calibrated. We also take this equipment and we go to the customer site. We'll actually do calibration on the site, so that saves the customer from having to ship it to it. So again, RF, part of being an amateur radio operator. Guess what? I turned a hobby into a business. Okay, this is just showing some of our employees set up. This is a EMI receiver from Roche Sources from Germany. And so this equipment is used to send stimulus to the equipment under test or to pull the data from it. Most of all of our calibration is done by automation. We do have a few items that we have to do manually. We also do vibration. There's companies that do testing for vibration and shock. So we calibrate the accelerometers. And so this device, it's hard to see here, he has a tiny shaker table, so the accelerometer is being calibrated or characterized on the platform there. This is one of our mobile systems for surge and burst. Companies, when you have a lightning strike outside, you can have 6,000 volts at this outlet. You get in your car, you turn on your air conditioner, guess what? You get a minus 150 volts spike plus a plus 300 volt spike. Well, guess what? The companies that sell products have to test for compliance that your product will meet these. And so they send that test equipment to us. Electrostatic discharge, we have ESD guns. Right now, I'm probably charged to 500 volts standing here. If I start sliding myself around this carpet, I may charge up to 10 or 12 kV. And there's different waveforms. If from just a direct contact with my finger, or if I have a key in my hand, it's going to have a different waveform. So we have to characterize that for the customer. So we do a ton of electrostatic discharge guns. So when you go buy a product, there's all this testing that goes on. This is kind of an example of our mobile test setup. This is what we put in a trailer. Our guys go to California, they go to New York, they go down to Texas. We also have a sister company in Canada. We have Liberty Labs Canada right now, and we're doing the same thing in Ottawa, a suburb called Canada. And so we've expanded into Canada at this point. We also do mechanical dimensional. Manufacturing facilities, they have calipers, micrometers, dial gauges, pressure gauges. We have equipment, we have laser equipment that we can measure to the nanometer. And so we have very high precision. So people that are manufacturing or production lines, they have tooling that they have to check their parts that they're making. We calibrate all that tooling. Again, we go on site. And you can see the gentleman has white gloves on. Some of these items have to be handled with, because the oil from your fingers. Plus, this is being done in a 68-degree room. Every manufacturing print is only valid at 68 degrees. So if you look at a production print, those dimensions are only valid at 68 degrees Fahrenheit. We keep ours within plus or minus half a degree. NIST has one that's within thousandths of a degree. They wear special suits and things to prevent the body heat from affecting. So at the National Laboratory in Baltimore, Maryland, they have special suits to prevent the body heat affecting the measurements. That's how precise they are. We're not that precise, but we have to keep legs. Here's some example of the micrometers and calipers and micrometers being calibrated. We also calibrate surface plates. We have a laser system. We actually do lapping. We take diamond dust. We actually will level these surface plates to a very tight tolerance. And here again, height gauges, gauge blocks. These are used as kind of a check standard by almost every manufacturer, machine shop in the United States. So again, we have antennas, we have electronics, we have mechanical dimensional. We're kind of a one-stop shop. You can come get pretty much everything you want calibrated at our facilities. We have vision systems for calibrating devices that are visual, and again, high accuracy within millions. And okay, now some fun things. This is the project we worked with the European Space Agency, the Mars Express. This is a mock-up of the satellite. We had to have a helicopter come from Colorado. What we had to do, we had to fly this helicopter 10,000 feet in the air, 5 miles downrange. This was suspended 700 feet below the helicopter because we had a full wavelength 6 megahertz dipole. That dipole cost $300,000. We actually had 4 prototypes that we wanted to make sure, because when you were trying to lift this off the ground, we didn't want to start with that $300,000 dipole, because that was the dipole that they were going to put on the satellite. And you'll see it has folding arms. So they actually had a signal generator in here, and this is the actual size, and it was all battery powered. And what they did is they had a fixed signal, and then we were to receive this signal on our large ground plane, and we wanted to see if it came out to what they calculated. Guess what? We had got almost to on the diamond with them, what we measured with what they calculated with the University of Iowa. I don't know if you know, the first satellite, Explorer 1, that was designed by the University of Iowa. Guess what? When Sputnik went up, guess what? The phones were ringing off the hook at the University of Iowa. Get to Vandenberg. They had a convoy. They loaded everything up for Explorer 1. They drove non-stop from Iowa City out to Vandenberg so they could get the Explorer 1 up. That was how much critical. They got a call, whatever it takes. we got to get that satellite up. We can't let the Russians get ahead of us. So there's some interesting stories with this. So this is a special lift helicopter that could hover at 10,000 feet. And this is a helicopter that's used in the Rocky Mountains. Okay, it's a little hard here. This is the actual dipole, and all these elements collapse. And so they have like an explosive device that causes this to fold out. So it's in a compartment, and when these explodes out, the antenna unfolds by itself. And so it's kind of like a very thin material and then a very flexible element, a conductive element inside. That's $300,000 there for just that antenna. Okay, this is when we had to have support for it. And these are some of the engineers from the University of Iowa. We had to have special support. So with the antenna above the satellite and below it, we didn't want it waving the wind. And I think, yeah, this is the final antenna. And a lot of care was taken. And everybody was very careful because this had to, once we got done with the testing of it, it was going to go and be installed on the satellite. Here you can see it in the unfolded version inside our dome. They're doing a visual inspection of the antenna. This is a view from the helicopter, so now you kind of get an idea of our site. We do a lot of bench level testing in here. We have 40 acres here. This is our site 1 that's insulated covered. Here's our site 2. Guess what I used for the receiving antenna? I used a 160-meter vertical from Germany, from the DX group there. I came up with a special coupler. We did our own calibration of that at 6 megahertz. And so, I forget the height, I think that was almost 75 foot in height was that vertical. And there was a bit of a challenge. We were concerned we got up, it was going to snap on us, but we got it up and mounted. And so now I have a 160-meter vertical that I can use for my amateur radio. So a lot of this you can see, there's some side benefits of having a business like this that you can apply. So very rural area, away from power lines, away from cell phone towers, very quiet RF ambient.
Can I ask you a question?
Yes.
How much land do you own around there? Are you afraid of somebody moving in?
No. We own 40 acres. We're very remote.
Okay.
And we're far enough off. Here you can see a little bit better. You can see the vertical here.
Oh, geez.
You can see that we mounted. So we were receiving. The helicopter was 5 miles downrange and up at 10,000 feet. Had almost all my neighbors came around. What in the world? This helicopter flying with this big metal box, flying around day after day. We did this for about 5 days because we had 5 different antennas. They had a very simple prototype, and each one progressively they wanted to learn from it before we did the final antenna. So we got lots of spectators that came out and to watch what we were doing. Here's the helicopter coming in. You can see here. Here's the Mars Express down here. Is coming in to actually get ready to hook up to it. And by the way, we got all of us, the company got free helicopter rides, which is kind of fun. Okay, this is the helicopter in flight. You can see up here, 700 feet down, and here's the support structure to keep that antenna vertically forward. You had to have some way to hold it. And this is basically just like the, well, like those floaties. You go to the swimming pool, and it was made of that type of material.
Are the elements on the outsides of it?
No, it's in the center.
Okay.
So the dipole element goes right through the center here.
Okay, sure.
Okay? So it was quite the deal to get all this set up, and then you've got the other half of the dipole below the satellite. Okay, they're in the process of lifting up. This is one of the earlier prototypes that you really can't see. It's just a thin wire that goes up through here.
Okay.
It's being lifted, and then the other half down below here. And it was really difficult to get this so everything would not kink or snap as we did it. But I think overall things worked well.
Got to wait for a wind-free day, I imagine.
Yeah, it worked out good. So you can see here the helicopter's coming in, getting ready to lift up. You can see here is the supports on the top side of the satellite, and then down below they had a weight on it to keep it weighted. Okay. Just another shot there of them picking it up. And then just, you know, this is, I forget what height this is, but again, you can see kind of an overview of the location there. By the way, I handed out some papers. Any of you guys want to come out and do field day this year? Give me a call. We'll set you up on the ground plane. We'll operate on the ground plane. And it works great with verticals. You've got the perfect ground radio system there, 50 by 80 meters. And you can really get that angle of incidence really lowered down low. Okay, now I'm going to show you a little bit about me as an amateur radio operator. I like to do backpacking and hiking, and I use a KX3 and solar power. So we were up in Maine and had this set up. So this is me. This is how I like to try to enjoy the hobby, is getting outdoors with it and using it for camping or hiking. And also I use a mountain topper. I really want to keep things light in my backpack. I'll use a mountain topper. And that's a great low radio, a lot of capability. And I usually use a buddy pole system for my antenna. And the secret there is getting that buddy pole tuned. My gosh, that thing works great. I carry a small little network analyzer with me, and I check it for, you know, the lowest reactance and, you know, as much pure resistance as I can get. And the antenna works great. And I went on my first de-expedition last year to the Dry Tortugas, to Garden Key Island. Fort Jefferson's there. It's the largest brick structure in the world. And so I went down with solar panels. My wife came down and helped us get set up. And so the Tortuga means turtle. So Tortuga, that's the reason we have a turtle on there. And I learned a lot. So if I do this again, there's a lot of lessons learned. But I had a blast. I spent 2.5 days on the island, and with 5 watts of power and a buddy pole, I worked 8,000 miles into Australia with that system. The one key advantage is you have, when you're close to salt water, you have what's called saltwater amplification. We're also experimenting with a tunable vertical antenna, that the antenna is inside a cylinder with salt water. We're using salt water to tune the antenna. So those are some things we're experimenting right now. They're looking at that on ships to be able to, without having to have mechanical devices, you just raise and lower the salt water content within the volume, and you can remotely tune the antenna.
Wow, cool.
So this is Fort Jefferson, the largest brick structure in the world. And this is started back in the 1820s, 30s. You guys know who Dr. Mudd is? You ever heard of it?
Mm-hmm.
Dr. Mudd was in prison there after. There's a saltwater crocodile that's down there. So I kept my eyes out for him. So I was out there working late. I was on the ground. I had some other visitors, which I'll show you here in just a bit. Lots of birds. There's a bird sanctuary down there. This is actually a photograph from where I was operating. So this is one of my views. Okay? This is where I operated. This is the bird sanctuary over here. I actually operated in this area. It's hard to see here. This is from top of the fort. So I was able to set up here and have my solar panels. A lot of the guys, they'll go out here, but there's just a lot of clutter. I just enjoyed being down here. So that's where I operated for the 2.5 days. And this is another view. There are people that come down and basically camp out on their sailboats night down there. This is my operation. They had some metal plating. This is the buddy pole. There's my KX3. And I had my solar panels laid out on the metal decking. Just a close-up of the buddy pole. I just used 2 ground radios, and taking the time to make sure it's tuned properly, I get tremendous performance out of that antenna. So taking more time to set up and getting a good match on it, and you can work so many stations with that. Another view, this is from where I operated. This is the view of the fort. Those walls are like 20 feet thick of brick. I forget how many millions and millions of bricks. Close up, I use the Gold Zero solar panels for powering my rigs. When I'm backpacking, I actually have one that just lays in the back of the backpack, so I'm hiking. I can actually charge my batteries as I'm hiking with it. 14.26, that's where I pretty much operated when I was on the island. There's an overview of Fort Jefferson. They used to have coaling docks. You come here, we camped, I actually camped here, we had our tent set up here, there's a beach here. I actually operated, right here is where I operated, and this whole fort is huge. You can't operate, you can't set your radios up on here. It costs $100 to get a special use permit for it, and I've been told it's a very rare island, for islands on the air to get, yes sir?
Is that where is that located? Off the coast?
70 miles from Key West, Florida. And it's a 2.5-hour ferry ride.
Is it south of Key West?
It's to the west, kind of a little bit south and west of Key West.
Okay.
It's out there in the middle of nowhere. But it's a blast. There's our tent we set up. My wife's brother-in-law came along, keep me company. And so when I got tired, I would come back here and sleep for a few hours and get up early and continue on. You've got to schedule. Camping, you have to look at a couple months, 2 or 3 months out to get reservations to camp. There's so many people who want to camp on this island. There I am. I just sat on the ground, very simple. The radio and the solar panels. But I had some visitors that kind of scared me in the night because I kept looking for that crocodile. I also did work the satellites. I've learned how to do this better. That was kind of my first attempt. I worked only about maybe 6 or 7 stations, and so it was kind of a learning curve. And I'm building a tracking system now with an Arduino computer that has a sun sensor that automatically, so it really works good. And I use 2 FT817s. So I've got 2 of these strapped to me here, to the Arrow antenna. And I also have a duplex radio, but I find having 2 FT17s works well for the satellite tracking.
I can see that.
There I am. They took a picture of me up from the top of the fort. You see I'm sweating. It got hot down there. It gets warm.
Yep.
There again, kind of how I'm setting out during the day. Here's my visitors, sand crabs. I'm setting it. Next thing I know, I'm not kidding you. This thing must have been this big around, and it's up by my foot. Scared me half to death. The next thing I know, I had a little headlamp. This is like at 12 o'clock, 1 o'clock in the morning. All of a sudden I'm looking, and there's hundreds of these things crawling towards me. So it's like I wasn't prepared for that. But then when I went back to my tent, there's literally thousands of these things crawling all over. So you had to watch where you step because they're all crawling around at night. But after I got used to them, it wasn't a big deal. Oh, that one got turned around. That's just if you can see the whip antenna there, the buddy pole. There's another one of my views from my operating station, seeing the sunset at night. So where else can you do a de-expedition and have a view like this? This is just kind of a overview. They have a lighthouse in the fort. Again, I was operating right down in this area, and just kind of give you a broad picture of the island there. Just a broader picture of me doing some of the satellite. So I alternated between HF and working the birds down there. Oops. Go back here. There's a big moat around this, and the crocodile has been seen in this moat. It evidently got washed down there in one of the hurricanes. It's not normal for them to be down there that far. There's people, if you go on YouTube, they've been snorkeling down there, and all of a sudden there's this crocodile that's swimming around. So you want to keep a lookout for him. So this is our crew. My wife, Lou, Mary Lou, she's back here in the back. This is her. Myself, this is her sister and her brother-in-law. They came down to help set up. Her brother-in-law stayed with me. The gals, they went back to Key West, and I don't know what they did. They must have partied or shopped or something, you know.
Is he a ham too?
Huh?
Is your,
No,
No?
he's
Okay.
a Calvin outdoorsman. I just kind of the first time have someone with me. And this is the end of the presentation, and you can see the t-shirts. We have t-shirts made up. I'm going to pause. Any questions? Yes, sir.
I had a question. When you did that, tested that bra, did you find any lumps on the mounts when you got finished?
No. No, we found that it really didn't couple that much energy. So, you know, because their concern was like acting like a dipole, and they wanted to see, you know, how much energy was being coupled in. So we basically hooked it up in a dipole fashion, and then measured the actual receive. We had various frequencies, you know, multiple harmonics that would be of that, and the final conclusion was no, that would not be a contributor, RF being coupled into the underwater.
Okay. And when you were doing the HF studies down there, you do anything with that ISM frequency on 13 megs?
Oh yes, we go all through there.
Okay, is there ISM frequencies below that?
I'd have to look at that. I'm on a couple committees. I'm on the American National Standards Institute committee,
Okay.
and the Federal Communications Commission is part of that. And right now, they're trying to see with this wireless power transfer and ISM if some of the rules overlap. It's aggressive right now for wireless power transfer. We have all kinds of agencies. There's other frequencies. 7 megahertz on the primary. They go up way up in the higher frequencies. You've got frequencies in the hundreds of megahertz that they're looking at doing wireless power transfer, all with loop antennas. And the other thing that's coming down is lighting, RF lighting. And that's going to be a concern for interference, you know, to the amateur radio frequencies.
Are your power lines buried to provide your power out there?
Yes.
I kind of figured they would.
Yeah, everything's buried. Yes, sir.
Why are they using 6 megahertz on Mars?
6 megahertz has a property of being able to penetrate the ground. And so they had a lot of analytic receivers on the Mars Express. So they'd be basically like a radar. They're looking for the return. So depending on the amount of absorption of the 6 megahertz, they could detect. And they actually did tests. So 6 megahertz was the ideal frequency for detection of water underneath the surface of Mars. And they were able to prove it. They did tests here, and the antenna, we can make the claim, we calibrate things that are out of this world. I can say that. And it is there circling the planet Mars right now. And if you ever just Google it, called Mars Express, European Space Agency, and you'll see a lot of the information on that. We're doing one around 3 megahertz for Europa, for the moon that's around the planet Jupiter. They're also wanting to see if there's water. I'm not sure why they're looking for water on Europa, but there's a project going on that right now.
go ahead. Go ahead.
Yes, sir.
Did you have good luck with Goal Zero? Were you running one of their
Yes,
systems?
I love Goal Zero.
Yeah.
It works great. It's one of the best power packs. It makes it simple. I can charge my USB. I can do 12 volts. And it's very configurable, you know. And if I need to add other battery packs, I've actually taken my KX3 with a 100-watt amplifier, 100-watt amp, and used the Goal Zero and be able to operate for 2 days without any trouble with solar panels backing it up.
Wow.
Any other? Yes, sir.
In our literature that we read, we frequently hear about certain minimum distances of clear space in order to measure antenna gains. And it seems like your business is working in very short distances.
Yeah, that's a great question.
And I'm particularly curious about what you support those antennas on. Are those all non-metallic?
Yes, all non-metallic.
Okay.
We operate in what's called a near free space. And this is per the American National Standards Institute, C63.5. And then we also are embodied by CISPR 16. CISPR is Communiqué International Spécifique Publical or Radial. It's a French document. And so most of the antennas are done at a 10-meter separation. And this is what they call a near free space. The transmit antenna is at 2 meters. If we want to try to go as near free space as possible, we'll put the antennas 4 to 6 meters up. Now, remember that helicopter? Guess what? We're going to get in free space. We're building a drone right now to do antenna pattern tests. And I'm going to answer that challenge. If you saw CQ magazine, well, guess what? We're going to also make that a fox hunting drone. So we're putting a very lightweight spectrum analyzer, a mini PC, and we're using a special type of GPS. I don't know if you're familiar with RTK. It's a differential GPS. We can get measurement accuracies within centimeters. So the positioning. So we're going to be flying around, and I'm looking at getting some articles for QST in the future, where we're going to give you some real-world antenna pattern measurements around beam antennas, antennas mounted on vehicles. Our customers ask us to do it. Right now, we use a very archaic method. We use a boom truck. We use a turntable. It takes us quite a bit of time. So by having a drone, we're going to suspend an antenna, just like the Mars Express. We've got a drone that will lift 26 pounds. So this drone will be pre-programmed with all the positions to fly around with the antenna pointed, gather our data. We'll be able to do a pattern measurement, whether it's a polar plot or a three-dimensional antenna pattern. So we're hoping to have that ready by June. So if you guys need to check out your patterns, your antennas, give me a call, okay?
Nice.
So, yeah, there's a lot of fun things. So the sheets too. I am looking for amateur radio operators. If you want to work with antennas, send me your resume. We are interested. We are growing. Again, we do roughly 16,000 antennas on those sites in a year. That's a lot of antennas, and throughout the year. Any other questions?
Cool. How many people have come to your site to do field day, and have you done that? I'm sure.
We are a local amateur radio group 3 times.
Yeah. Okay.
And again, if anybody's interested in coming out on field day, let me know. I'd be happy to sponsor. We've got places where you can camp. I've got restroom facilities, and we set the antennas up on the ground plane. Verticals work fantastic on that ground plane, and we've even mounted a 160-meter vertical.
Right.
And for so.
Yep.
If anybody ever wants to come out for a tour, give me a call. I welcome any amateur radio operator. If you want to come out and tour the facilities firsthand, give me a call. You're welcome. We'd love to have you.
How about group tours? How many?
Yes.
How many?
I've taken up as, I think we could handle a group this size. We'd probably divide it up in a couple smaller groups. But I've had some students out there. We had like almost 75, 80 students. That was a challenge one day. And, but yeah, we do tour groups that come out. So if you'd like to do that sometime, we'd be happy to do it.
How far out are you?
We're 60 miles from Omaha. We're 7 miles off Interstate 80. The test site is in a farm located in Kimballton, Iowa, north of Kimballton, Iowa.
You're north of the Interstate 80 there?
Yeah, 7 miles north of Interstate 80.
Yeah.
So, you know, roughly, like outdoor sites, roughly 60 miles.
Kind of the Atlantic area. Yeah, it's a little bit before Atlantic, but not too much.
Yeah.
They're all wind chargers, aren't you?
Yes.
Okay. Like Minnie, Marnie's a little bit further than you too.
Marnie's, no, closer than us. You'd hit Marnie before you'd hit Elkhorn.
Okay.
Yeah.
You're between Marnie and Atlantic then?
Yeah, Marnie and Atlantic. Mm-hmm.
To the going east.
Yes.
And north, both of them.
Mm-hmm.
Okay.
And the Danish windmill.
Yes.
Yeah, the Danish windmill.
Yeah. Okay.
Not the Dutch windmill, but the Danish windmill.
Okay, well, thank you for having me.
Thank you very much.